This conference will now be recorded.
Hey, hi guys. So today we'll talk about Spark structure streaming. But before talking about Spark structure streaming, let's try to understand one important question. So in the interviews, you may get a question such as, have you worked on batch processing applications or stream processing applications? So this could be one of the possible interview question. Then I would suggest to say you have worked on both. So now we will try to understand what is the main difference between batch processing applications and stream processing applications. So in the batch processing applications, we get the data at the regular intervals of time, such as we may get the data on daily basis, or we may get the data on weekly basis, or we may get the data on monthly basis. So basically, there is specific time in a given day. Let's say you might get the data on at 11 p.m. Indian time. Sorry, not Indian time, any time. So basically, you may get the data at 11 p.m. in the night, or you may get the data on weekly basis, let's say on every Sunday, or you might get the data on monthly basis, let's say on the 15th of every month. So the point is very clear. If you get the data at a specific time and you try to take the data, process the data by using Spark to generate some output. That is nothing but an example for your batch processing application. So in fact, your monthly bills that are getting generated for such as your mobile bill, your internet bill, all those bills are examples for your batch processing application. As you can see here, there is a specific time at which your data gets generated. You take the data, process the data by using Spark to generate the output. So this is in batch processing application. So in stream processing application, you will be getting the data throughout the day in small intervals of time, such as every 5 seconds, 10 seconds, you'll be getting the data. So there will be continuous flow of data throughout the day. So then Spark will check if there is any new data coming or not. So as soon as the new data comes in, it will take the data and then it will process the data to generate the output. Example for stream processing applications is nothing but Uber. So Uber app basically, it expects that let's say you are the customer of Uber and you wanted to book a cab immediately, and you try to book a cab within 1 or 2 minutes of time, you should have the cab booked, right? Let's say if the cab is getting booked after 1 hour or after 2 hours, will you be interested to board the cab? No, right? Everything should happen within a span of 1 or 2 minutes of time. So Uber uses Spark structure streaming quite a lot. As I told, in Spark streaming applications, you'll be getting the data in small batches throughout the day. Spark will take the data, process the data to generate the output. Now let us talk about some of the use cases of stream processing applications. As I told, stream is nothing but a continuous flow of events. If you take Twitter, if you tweet something, that is considered to be as an event. So if there is a continuous flow of tweets, it's nothing but stream of tweets. And sometimes when you board an Uber cab, you'll be able to exactly figure out the time at which you'll be reaching your destination, right? So the GPS location of an Uber car is an event. So continuous flow of GPS locations is a stream of GPS location of Uber cars. So with the help of GPS locations tracking, you can get to know your exact location right now, and also you'll be able to figure out at what time you'll be reaching your destination. And also a web application, let's say you log into Amazon website and then you try to navigate through different sections of product. Let's say you might be checking the sportswear, or you might be checking some electronic gadgets and all that. When you click on any link in Amazon website, it will generate a log message. So all those log messages are gathered by Amazon, that we generally call it as user clickstream data. For every click that you're going to make, it's going to generate a stream of log messages in the background. So that is how you might be getting some offers and discounts and alerts based on the clicks that you make. So let's see some of the use cases again. Uh, so one of the example could be fraud detection system in Amazon. So once you place an order in Amazon, so Amazon have a very powerful fraud detection system in place, which will decide whether the order that you have placed is a genuine order or fraudulent order. If it is a genuine order, it could be accepted. If it is a fraudulent order, then it could be cancelled automatically. And as I told, log processing platform is also one of the example. So basically, when you make any click in any website, automatically those log messages are generated. It could be processed automatically. You'll be notified. And taxi sharing platforms such as Uber is also an example for Spark structure streaming use cases. So let's say you are a customer of Uber and you try to place a request for a cab. So Uber uses Spark structure streaming in the background to match or to connect the customer and then the driver. And finally, the cab gets allocated to the respective customer. Even Twitter uses Spark structure streaming quite a lot. So sometimes you might have seen some of the tweets are getting trended, right? So Twitter uses sparse structure streaming in the background. It will take the tweets or hashtags, then it will tell you what is the latest trending tweet in the last 1 hour or last one day, right? Twitter uses sparse structure streaming quite a lot. Another very interesting use case that is very hot in the market these days is in IoT devices. So IoT basically stands for Internet of Things. So in any industrial plant, you might have seen some IoT sensors getting installed, right? Or IoT devices. Each of those will be generating huge amount of data or messages. All that data, we are going to read it by using Kafka. Again, we haven't seen about Kafka yet, but the idea is it uses Kafka in the background to get the data, and then we use Spark structure streaming to process the data, and we can populate or show any dashboard or report which changes every second because it is streaming data. So these are pretty interesting use cases where Spark structure streaming used quite a lot. Again, these days, slowly the interviewers are also asking some questions on Spark structure streaming. Okay, before moving on, any questions? Okay, I believe there are no questions. We are good to move on. So let's move on. So let's talk about stream. What is a stream? So stream is nothing but a continuous flow of events. So if you talk about this important terminology called as batch interval, what is the meaning of batch interval? Let's say the batch interval is 10 seconds. So whatever data that comes in a span of 10 seconds of time, all that data is actually kind of grouped and created a data frame out of that. You can see that for every 10 seconds, it's going to create a data frame. After every batch interval, you get one data frame. Whatever data that is coming in a span of 10 seconds of time, all that data is grouped as a one data frame. And then you might hear this term called as unbounded table. What is the meaning of unbounded table? So as soon as the new data comes in your data stream, all those data or all those records are added or appended to the unbounded table at the end. As you can see here, all those records are getting added, appended. Hence, it is called as unbounded table. So this is the simple architecture of Spark structure streaming. You have your input. So before talking about this, let me do one more thing. So you have to understand about one important terminology. So let me make a note of that. So the terminology that we're going to talk is so so input or source both are same. Output, destination, target, sorry, 1 minute, target, and then sync. All these are same. So don't get confused. Sometimes in interviewers may ask you what is your source and what is your target, or some people may say, okay, what is your source and what is your sync. So don't get confused there. So they are basically talking about input and output. So now let's go back here. So you have your input streaming sources where you get the data in the streaming fashion, and you try to read it into a table or a data frame, process the data, you get the resulting table. And we'll be checking continuously if there is any new data. Accordingly, we'll be filling up this output sync. So on the left hand side, you can see the list of all the supported streaming sources. You can use Socket, you can use Kafka, Flume, HDFS or S3, Kinesis, Twitter. All these are your sources. On the right hand side, you have your syncs such as HDFS, database, dashboard, or console. All these are going to act as your syncs. So you take the data from your source, process the data using Spark Structure Streaming, push the final process data into any of the sync. So to start with, what we'll do is we'll start with socket source and console sync. That is, we are going to read the data from a socket, process the data by using Spark Structure Streaming, push the process data onto the console. So that is the idea. Let's get into the hands-on. So basically, I'm going to show the hands-on by using PyCharm. So I believe you guys have already installed PyCharm. If not, please do it. I think we don't need to install. As I told, you will automatically get it from the Anaconda. So if you want, I can show it once. Search for Anaconda Navigator. So it will take a while to launch the Anaconda Navigator. Once it is launched, you will automatically find an IDE called as PyCharm. Again, guys, remember this interview question. It asks you which IDE are you using. IDE stands for Integrated Development, Integrated Development Environment. Integrated Development Environment. So the example is nothing but Python. In the interviews, if you get this question, you can see that you are using Python IDE in your data engineering project. So you can see that you get PyCharm here. You can see that PyCharm community version is something that we're going to use. There is a launch button here. Click on this launch button. It will launch PyCharm. So as soon as you launch PyCharm, it won't be suitable enough to start coding with Spark. We will see how to set up Spark now. So first click on file. So as soon as you open this, it will show something like this. What you can do is you can click on new project. You can give any name. Let's say Spark Structure Streaming S Practice December 2022. I'm giving some random name. You can give anything. Then hit enter on your keyboard. So it will take a couple of minutes to do the initial settings. Then you will first check whether you have the Python setup correctly or not. So you can see that they are giving a sample file called as main.py. You can run this file to verify whether you have the Python setup ready or not. At line number 13, you can see a play button. Click on the play button. Then click on run main. So you can see that it's showing us hi PyCharm, and you can see exit code is showing us 0. So if you see these two lines, then it's an indication that your PyCharm is fine with respect to Python point of view. But now we have to configure it to work with Spark. So to do that, you can click on File, Settings, and on the left hand side, click on Project. Click on Project Structure, and here you can see Add Content Root. Click on that. So let's go to C drive because that's the place where I have my Spark available. Then I'll go to Python lib. So these are the two files that you have to select. So look at the path I'm in: C drive, Spark, Python, lib. So select these two files. How to select these two files? Use Shift and down arrow on your keyboard to select these two files. Click on OK. Bottom right corner you can see apply button, click on it. Then you can see bottom right corner you can see OK button, click on it. That's it. This is what is required to practice Spark on PyCharm. So then let's expand this. Let's start creating our files. Right click, say new Python file. Let's say Spark structured streaming. The practice. So select Python file from these three options. If you want, you can actually change the name, rename the file. I want to give the correct name. So this is where we are going to write our Spark structured streaming code. Again, on Spark shell, on Databricks, you will get the Spark session automatically. But on PyCharm, on Jupyter Notebook, you won't get the Spark session. You have to create it on your own. So how to create the Spark session? You can say Spark equal to Spark session. You can see red color line here. Place your mouse pointer there, and you will see import option. Click on import. It will be automatically imported. So Spark session dot reader dot app name. App name can be anything. Let's say Spark structure streaming. Dot master. So master set it to local. So we have learned that the cluster resource manager option is nothing but local when you develop your code. Hence I'm setting master as local dot create. And then if you want, you can keep the entire code in parentheses, the round brackets. Then you can break it down into multiple lines such that this dot comes in the next line. So, but now to confirm whether we have the Spark session object available or not, what we can do is you can say print of type of Spark. Type it anywhere, then say run. So guys, you can see that you have got the Spark session object available, and moreover, look at this exit code. If you see the exit code as 0, that's an indication that your code ran successfully. And you can see that we are getting the Spark session object. So then what we can do is we can see one important thing. So we were using Spark session dot read to get what? Data frame reader, right? This is used to create batch data frame. So what about streaming data frame? That is read stream. This will give you data stream reader to data streaming data frame. So I can show that. So let's say print type of Spark session dot read stream. Let's run this. Now have a look here. We are getting data stream reader. So to create a streaming data frame, you have to use data Spark session dot read stream. Understand this difference between these two. right? Now let's see how to create the streaming data frame. So the streaming data frame is nothing but the unbounded table. So unbounded table that I was talking about is nothing but the streaming data frame. Let's see how to create that. Stream df equal to Spark session dot stream dot format. So here I had to mention the format. Format is nothing but the socket. Now what is the meaning of socket? Here I wanted to mention the socket as my source. Hence I am mentioning format as socket. What is socket? Socket is a combination of host and port number. Host colon port number. So in our case, I'm going to basically install something called as basically to demonstrate this, I wanted to install a software. I already have it installed. Let me do one thing. Let me uninstall it, and then I can show it install from scratch. So I have something called as nmap. I will uninstall this. Close. And I'm going to install this software called as nmap. This is required to demonstrate the socket, reading the data from socket. So here, guys, 1 minute. Just give me 1 minute. And it's nmap download. Just click on this second link. Then you can see that there is a download button here. Scroll down. So you can see that there is something called there is a link called as nmap 7.93 setup exe. This is what is required to download nmap. Again, guys, if you're using Mac, you don't need to install this, but if you're using Windows, I would suggest to install this. I'll tell you why I'm installing this. So I need to install two softwares totally. One is this nmap. So this nmap has been installed. So let's try to open that. And I'm trying to install the same. Just the default steps. You don't need to change anything else. That's all. Once this is installed, I would like to install another software called as git bash. Again, I already have it installed. I would like to uninstall the same. So guys, now what you should be doing is you should say git bash download. Click on the first link. So here I'm using Windows, hence you can just click on download for Windows. So you have to click on 64-bit git for Windows setup. Click on it. Again, if you're using Mac, you don't need to install this also. But if you're using Windows, I would encourage you to install this. So let's wait for some time. So it's downloading Git. So let's wait for some time. So why am I installing these two softwares? I'm installing Git because to run any Linux-like commands, right? Linux commands on Windows, this is what we can use. And the reason why I'm using Nmap to download is nothing but to read the data from a socket, right? To read the data from socket, and then we will process the data by using Spark Structure Streaming. So for the sake of socket, I'm installing Nmap to run any Linux-like commands, and to run those commands, I'm using Git Bash. So it's downloading. Let's wait for one more minute. So it's downloading, almost done. So I'm going to install it now. Again, the default steps. I don't need to change anything else here. Just the default steps. You can see that I'm not changing anything. I'm just going with the default steps. So I have installed both now. So once this is done on your local machine, you can just search for Git Bash, open that. And now we have installed Nmap. To confirm whether Nmap is installed or not, you have to type a command called as ncat space -- help. Enter. So if you see this output, then your Nmap installation is successful. So I want you to focus on a couple of options here. One is -l. L is nothing but listen, and -k, k is nothing but keep open. So these are the two options that we are going to use. So because as I told, socket is a combination of host and port number. Because it is running on local machine, it will be local host. And port number can be any 4-digit number. Let's say 1234 is the number on which my socket will run. So what I mean here is, so you can say ncat space -lk, say 1234. Hit enter. So my socket is running on the port 1234 on the local machine. Whatever data that comes in the local machine on the port 1234, all the data could be consumed by Spark Structure Streaming application. Now let's go back to our code. So that's why I have mentioned the format as socket. Then you can mention dot option. You can mention the host. Host is nothing but localhost, and then dot option. You can mention the port number. The port, let's say 1234. Then say dot load. So this should return a streaming data frame for you. Let's break it down into multiple lines. So Spark session dot read stream, because we want to create a streaming data frame, and format is socket, and we are reading from localhost on the port 1234. One more thing which I would like to confirm is print type. You can see the type of this streaming data frame. Also, you can do one more thing, print stream data frame dot eStreaming. So eStreaming is nothing but a boolean value. It will return a boolean value whether it is really a a streaming data frame or not that we're trying to create. So let's run this. So you can see that it won't show it as streaming data frame, but it is a data frame. That is, this is what is required. And you can see it is showing us true, which means it is saying that, okay, this is a streaming data frame, right? And you can see exit code is showing as 0. So now we are good to go ahead. So one more important thing. So my socket is running on port number 1234, and I should also mention the same port number here, 1234. If I mention anything different, then it won't work. Let's say 5678. Then let me run this code. It won't be showing any error right now because I'm not calling any action, right? Read stream is just a transformation. But once I write some code and then start doing the things, you'll see the difference. For now, let me put it back to the one that I want. So now I wanted to write this data as it is. To write the data as it is, I'm going to say stream data frame dot write stream. Stream data frame dot write stream, and then I want to write it to the console. Hence, I'm going to mention the format as console. Because remember, you want to read the data from socket, process the data by using Spark structure streaming, write the output to the console or the sink. Hence, I'm mentioning the format as console. And then you have to say dot start. So let's do one more thing. Let's try to assign this to streaming query equal to, and I want to keep everything in the parenthesis, and then I want to break it down into multiple lines. Let's do one more thing. Let's try to see the type of the streaming query. Type of streaming query. Let's try to run it. So you can see that you're going to get a streaming query type whenever you call write stream dot format dot console dot start. And by the way, one more thing which I wanted to tell you, whenever you call data frame name dot, whenever you are calling data frame name dot write, so here you have, let's say data frame name is df, and when we were mentioning dot write, you were getting data frame writer, right? So this is to write the data by using a batch data frame. But now when you say data frame name dot write stream, you're going to get a data stream writer to write the streaming data frame. So I can show that. So here I can just say int stream df stream df dot write stream. Let's run this. You can see data stream writer. So this is what is required. So why am I talking about all this? Because one of these could be asked as an interview question possibly, right? Be prepared. So they may ask you, okay, how do you get data stream writer? You have to say data frame name dot write stream, or they may ask reverse. Okay, what do you get if you say data frame name dot write stream? You're going to get data stream writer that is used to write the streaming data frame. So that's why these four are really important. Okay, now we have better clarity among all those. So let's remove this. Now let's start writing the data. So again, one more interesting question that you might get in the interviews is, there is one line that you will mention in most of the streaming applications. What is that? You have to mention streaming query, which is nothing but this dot await termination. That is, these are the streaming jobs, and these will be running 24/7 continuously until unless you stop your application. So that's the meaning of streaming query dot await termination. So they may ask you, what is that one line that you mention in your streaming application? Always streaming query dot await termination. Okay. So now let's do one thing. Let's start running this code. Right click anywhere, start it. So you can see that there are no errors now, but you can see that it started processing the data. There is no data, right? You can see I'm not pushing any data here, hence it's not displaying anything. But now let me push some data here. Let's say hello. I can see it showing us hello. Let's say world. I can see world, right? So that's how you, whatever data that you push here, the same data is read, and then it's being shown here, right? And as I told, these are the streaming applications, and they'll be running continuously, and it is still running continuously. How do you figure out that? Top right corner, you see a red color button. You can see saying stop triple S practice, which is nothing but this application is still running continuously. If you want, you can stop it by clicking on it 2 times. Okay, you can see that it's showing us exit code -1, which means you have stopped this application, right? Now I'll do one thing. I'll change this port number this time. Let's say I'll change the port number to 5678, right? And I will stop this socket also by using Control C on your keyboard. If you see Control C, it will stop that. Then I will start it once again on the port 1234. Observe the important difference. My socket is running on 1234. My streaming application is looking for the data on 5678. So there'll be a mismatch. Hence this will fail. But let me demonstrate that. You can see that it is failing. Exit code is showing as 1, and you can see the difference clearly. Connection refused connect. So basically it is not able to connect. We are saying that okay, go and check on the port 5678 on the local machine. Whatever data is there, just get the data. But nothing is running on the local machine on the port 5678. In fact, it is running on the port 1234. So to fix this, there are two ways. Either you change this to 5678, the socket part, or put it back to 1234 on your streaming application. Up to you. Now, just to keep the thing simple, I'll change this back to 1234. Now, if I start running it, you should not see that error. You can see batch 0, which means things are good. I can start pushing the data. Low. Okay. I can see that things are working as usual. So make sure you use the correct port numbers and use the correct port numbers at both the places. You can see that I'm using 1234 on the socket side. The same port number I'm using at line number 14 for the correct port number also. And these are the streaming applications. You can see that these are running continuously because we have mentioned this line called as await termination. Top right corner, you can see that red color button. Click on it twice to stop it. Right now, let's comment out these lines. So let us say, um, let us comment out these lines. So I can add multi-line comment in Python by using this. If you remember, if it is a batch data frame, we were using data frame name dot show. It was giving us the results, right? Let's try using the same data frame name dot show. Remember, this is a streaming data frame, not a batch data frame, but still I'm giving a try. Let's see how it goes. Let's try running the query. You can see that it is failing. Exit code is showing us 1, it is failing. Queries with the streaming sources must be executed with write stream dot start. So the point is very clear. If it is a streaming data frame, you cannot use the batch data frame action such as show. To preview the data, you have to definitely use write stream.start. Only that is a possibility of looking at your data frame content if it is a streaming data frame. So let's put it back to the same. So I will remove this show and I will uncomment these lines. Now let's try running it again, right? So let's go back. So let's try to run this application once again. So now you can see batch 0 is showing as value. So because I'm not pushing anything, hence you are not seeing any values. Let me push again. I again. Right? So that is how you can actually deal with the streaming applications, guys. So again, this is very important concept. Um, Again, to be frank, you won't get many complex questions in streaming, but if you say that you are working on it, it will add a lot of value. Again, we should be able to manage the interview questions. Most likely, whatever questions that you might get in the interviews could be from today's session and tomorrow's session. So today we just started with understanding how to start with streaming applications. Tomorrow we'll see a lot many things. So tomorrow we'll talk about what are the different write modes that we have got, and we have got something called as triggers. What are the different types of triggers? How each of those works? All those things we are going to talk tomorrow. Okay, but more importantly, before coming to tomorrow's session, I want you to set up this. I want you to run whatever examples that I ran today, so that you will feel comfortable in tomorrow's session, because tomorrow's session might be a little tricky, but if you practice today's session, that should be easy for you. Okay, so before coming to tomorrow's session, the assignment is finish off today's sessions. That should be more than enough. Okay, so the idea is next week we are going to deal with couple of projects. One is with the combination of Kafka and Spark structure streaming. So hence for that you have to practice today's session and tomorrow's session. And another project would be a combination of AWS big data components with Spark. So those are the two projects that I want to cover next Thursday and Friday. Hence the prerequisite should be clear. You have to practice these sessions, only then you will feel comfortable during the project session. Okay, so that's all for today. Let us catch up tomorrow. We'll continue with Spark structure streaming tomorrow again. See you then. Bye.